Right. Sometimes students may not be able to get the correct answer while finding the length of certain sides using ratio of corresponding sides in a similar triangle. So in this example here, we are given triangle ABC. It's similar to triangle ADE, and we're given all the different informations for length AC, CE, BC, AB, and so on. And then part A, we're supposed to write down the numerical value of AC over AE in the simplest form. Right, so since we know that, sorry, not that we know, since that we are given in the questions that triangle ABC is similar to triangle ADE, then we can use the other two conditions, meaning we can use the SSS similarity test to compare ratio of the corresponding sides. So this ratio of the corresponding sides will be the same. Right, so back to the similar triangles. So AC, to find the ratios of AC over AE, uh, AC is given to be 5 cm, AE will be 5 plus 4.6 because AE is equals to AC plus CE. Right, so the ratio of AC over AE will be 5 over 5 plus 4.6, 5 over 9.6. Now, the questions require you to find the numerical value of AC over AE in the simplest form. So if you leave answer as 5 over 9.6, this is not the simplest form because 9.6 is a decimal number. You cannot have a decimal number in the fractions. So what you can do is you just simply use the calculator, use the fractions symbol in the calculator, key in 5 at the numerator, key in 9.6 at the denominator, and then the calculator will simplify for you to get 25 over 48. Right? If you don't use the calculator, then you'll be quite tedious, but it still can be done. You just take 5 divided by 9.6, and then you convert 9.6 into a mixed fraction. And then after that, you change the divisions to multiplication and so on and so forth. Okay, easier way would be just using the calculator, plug in the value, and the calculator will simplify it for you to get 25 over 48. So 25 over 48 will be the simplest form. The next part of the questions will require you to find the length of BD. Right, so I'm going to show you the solution done by two persons, and then from here we will address some misconceptions. All right, I'm going to show you Ong's working. Right, this is what Mr. Ong has done. Right, he compared the ratio of, he uses side AB and he find the and side AD, and he find the ratio of AB over AD. Now, since we know that the two triangles are similar, so the ratio of the corresponding sides will be the same. So the ratio for AB over AD will be equals to AC over AE. Now in part A, we have already found the ratio for AC over AE, which is 25 over 48. So you can just plug it in. And then looking at the diagram, the value for AB is 3.6, plug it in also. And then AD being the unknown, so we just leave it as AD. Right, so simplest way will be the shortcut, just do a cross multiply. AD multiplied by 25 will be 25 AD. 3.6 times 48. To find AD will be 3.6 times 48 divided by 25. That gives you 6.912. But bear in mind that you need to find the length of BD. So you have to, BD is equals to AD minus AB. So we use 6.912 minus away your values of AB, which is given to be 3.6. So the answer for BD will be 3.312 centimeter. Okay, I'm going to show you another person's working. And this is the working done by Mr. Lee. Right, so what Mr. Lee has done is he uses AB, define the ratio of AB over BD, which is equals to the ratio of AC over AE. Similarly, for AC over AE, we've already found it in part A, 25 over 48. And then the value for AB is 3.6. So he did a cross multiply also, and he get BD equals to 6.912. Right, so in both solutions, which one is the correct one? Do you think Mr. Ong's working is correct, or do you think Mr. Lee's working is correct? Have you decided? Right, I'm going to show you my answer now. Yes, the correct answer is Mr. Ong's working. Mr. Lee's working is incorrect. Why is that so? Right, let's go back to Mr. Lee's working. When we talk about ratio of corresponding sides, we are referring to ratio of corresponding sides of similar triangle. The keyword is triangle. So when you compare sides, it must be sides of a triangle. So what Mr. Lee has done is he compared AB, which is the side of triangle ABC, but BD is not the side of triangle ADE. BD is the side of the trapezium. So you can't be comparing the length of a triangle with the length of a trapezium on the left hand side. And then on the right hand side, you actually compare the ratio of AC over AE. The right hand side is correct, but the left hand side is wrong. So if you want to compare ratio of the corresponding side of the triangle, you must remember you have to compare the sides of a triangle, not the partial side. Okay, so in this case, Mr. Ong's working is correct. He compared AB with AD and AC with AE. So that is the reason why some of you don't get the answer. Okay, this is the misconceptions that I want to address here in this example. Hope you can understand.